All right, welcome to Lab 2. And something very important starting this lab that I want to tell you about is that you can work in pairs. And this is for labs only, not for homeworks, okay? So starting this lab, you can work with a partner. Pairs means groups of two, no more than two, all right? You can assume that I'm going to let you work in pairs until the end of the semester, unless I say otherwise. But you should both still submit separately to the autograder so that I can give you a grade separately. But you should include a comment in your code saying who you worked with. Okay? That's the only requirement that I'm looking for, just to make sure that you didn't steal somebody else's code. That's the idea. Okay. Yeah, if you're wondering about how to best, most efficiently give your code to someone else and have them give you their code, and I'll just keep going back and forth like that, I can totally tell you about some cool ways to do that. Otherwise, I will let you figure out how to best do it. Okay, so this lab is all about RSA. It's chapter 9 in your book, and it is mostly straightforward. Okay, you're going to implement RSA, get the starter code as usual. These are all the files that you'll see, and you'll, for the most part, just follow the idea. Okay, follow everything. But let us get started with one thing that's going to be in the lab that you may have not seen before. It is the pair type in C++. It's in the utility header. So let's go and look at that. A pair, here's the utility header. A pair is just a type that holds two things of any type. So T1 and T2 are the inner types of the pair, and you can put two things into a pair and get those two things back out. So here's an example of here's a pair of strings and doubles called product 1, and some more strings and doubles. And then to make a pair, you say make pair, which is easy enough. And then you give it the two things that you want to make the pair into. Okay, and then you can get them out with first and second, but let me show you a quick example of that just for fun. So yeah, pair can take any two types, and it's a type that holds two things. Oops. For example, here's pair int bool. You can make a pair called p. It's just another variable with make pair, and you have to give it two things that you want to put inside of it. Okay, so let me give you a quick example of that before we go on to what's going on in the lab. So maybe we'll say, let's see, is this code from class? Yeah. So let's make pairs.cpp. Let us make this. Let's make it large for you. There we go. So we're going to include utility, and then we'll say pair of, I don't know, int bool is fine, probably. Pair int bool p equals, and you say make pair. The first thing has to be an int, and the second thing has to be a bool, given the way that I've declared them. Okay, 5 and true. And that's my pair. Okay, so now I have a pair p that I can go and use. The way you use a pair is to extract those things. So, oops, if I go back to the slides, you can say p.first and p.second to get those individual things that you put into it back out. Okay, so that is pairs in a nutshell, and that will be useful for one of the functions that you implement this lab. Okay, so let's, I don't know, just quickly see out p.first and p.second. Oops. It doesn't feel like auto-completing tonight. Okay, let's compile that. And we get 5 and true, or 1. So that is a pair. You can just put a bunch of stuff into one variable. It's kind of like a size 2 array or a vector, something like that. But it's useful when you just have two things that you want to keep together. Okay, so those are pairs. Now, let us go to the lab write-up. All right, so what's going to happen is you're going to implement only one file, and that file is rsa.cpp. Okay, so there's not a lot of instructions. There's just a few functions in rsa.h that you will implement in rsa.cpp. So let's go and look at those. And they're mostly in your book. Okay, pretty much all of them are in your book. Okay, let's take a look at rsa.h. So you're going to make the RSA algorithm in full to be able to encrypt integer messages. Okay? So you got these encrypt and decrypt functions down here. That's eventually what you're going to get to. Okay? That's all this stuff is going to culminate in you finally being able to encrypt and decrypt things. But to start, you might want to look at a few of these functions. The one that you can complete right now is the two that you can probably complete right now is powmod and then GCD. The rest we'll talk about next week, and you'll have plenty of time to implement those, or if you want to read ahead, go for it. So powmod computes x to the y, so x to the power of y, mod m. Okay? So you're just going to use a loop, use some modulus operators. Shouldn't be too bad. That is what I call powmod. Okay, x to the y mod m. And then the next function that you can implement right now that we've talked about in class is GCD. So you can implement that to find the greatest common divisor of two things. All right? And the rest of these you will understand a whole lot more next week when we go over them. But I wanted to release this lab now so that you can get started on what you do know. Okay? So that is that, and you're going to go and implement all this stuff in the .cpp file. Here it is. So all of these things will make sense next week if you haven't read about them in your book yet. Like what is n, what is phi, what is e, all that stuff. How do you encrypt? How do you decrypt? They're all very simple equations. It's not too bad. I just want to make sure you get started now, though. So powmod and GCD you can definitely implement now, and the rest you can either read ahead or wait. The one problem that's going to come up is the extended Euclidean algorithm. Your book does not really talk about these, and it looks like I forgot to complete this definition here. Let's go to this page, okay? Because Wikipedia is the answer. The extended Euclidean algorithm does a little bit more than finding the GCD. It finds some numbers that equal the GCD. It finds x and y such that ax plus by equals the GCD of a and b. Okay? Let's make these all spelled out. And thank you. Okay, so you can find these two special numbers when you find the GCD. It's possible to extend the Euclidean algorithm, and I will go through examples of it in class, but not the algorithm itself. And the algorithm itself doesn't also seem to be in your book either. So that's okay. If you go to this Wikipedia page, down here there is some pseudocode that you can just copy. Okay? That's all. So you're going to return back two numbers, and so that's why I had to teach you about pairs. Okay? So you'll give back one of these pairs, either this one or this one. I cannot remember how they're explaining it here, but one of those is the answer. Okay? You're finding potentially they're the coefficient, so it might be this one, but you'll have to double check me on the tests. Okay, so that's what I wanted to talk about. Just implement this extended GCD function from Wikipedia. It should match everything that we talk about in class next week. And yeah, it shouldn't be too much code. It's just going through all of those definitions of all the stuff that we're learning and actually implementing them. Okay? So this shouldn't be too bad. We're going to complete our study of RSA next week, and then you'll have a week to go and implement all of this. Okay? So get started, though, on powmod and GCD. The rest, I promise, will make sense after next week's lectures. All right. Yeah, I think that's everything that I wanted to talk about. It's not too much of a technical lab this time. Okay, so enjoy that. And I've put everything into a testing file, testrsa.cpp. There it is. And so it tests your powmod function. So you can at least get one test passing now. Test extended GCD, multiplicative inverse. We'll talk about what those mean. And then test encrypting things with RSA. Okay? With special P and Q values, which we have chosen. Yeah. So go ahead and run this. You'll compile it as normal with a make file. You'll do, where is it? Make test RSA, as usual, the name of the file. and then you'll run it with /test_RSA, and then just get them all to pass, all those tests, and you are set. You get full credit. Those are the tests that I will be grading you on. Okay, so you'll turn this in as usual, turn it into lab 2 at CSCI26, and you'll turn in the one file that you changed. And so this is why you can't change any of the others. It's because I'm using the defaults. So you can only work on rsa.cpp, okay? And yeah, that's it. All the tests passing gives you 35 points and 5 for each test, if I counted right. Yeah, that's all I got for you. So good luck on this. Please yell at me if you have any questions. Remember that you can start working in pairs. Feel free to ask on Discord if anybody wants to be your partner. That's the perfect place for that. And yeah, I will see you next week. Good luck on this.